Using stream processing in TDengine. It's often necessary to clean and pre-process time series data before storing it permanently in a database. In a traditional time series solution, this generally requires the deployment of stream processing systems such as Kafka or Flink. However, the complexity of such systems increases the cost of development and maintenance. With the stream processing engine built into TDengine, you can process incoming data streams in real time and define stream transformations in SQL. Incoming data is automatically processed. The results are pushed to specified tables based on triggering rules that you define. This is a lightweight alternative to complex processing engines that return computation results in milliseconds, even in high throughput scenarios. The stream processing engine includes data filtering, scalar function computation, including user-defined functions, and window aggregation, with support for sliding windows, session windows, and event windows. Stream processing can write data to supertables from other supertables, standard tables, or subtables. When you create a stream, the target supertable is automatically created. New data is then processed and written to that supertable according to the rules defined for the stream. You can use partition by statements to partition the data by table name or tag. Separate partitions are then written into different subtables within the target supertable. TDengine stream processing supports the aggregation of supertables that are deployed across multiple vnodes. It can also handle out-of-order writes and includes a watermark mechanism that determines the extent to which out-of-order data is accepted by the system. You can configure whether to drop or reprocess out-of-order data through the ignore expired parameter. Let's look at the syntax for creating a stream. Now, let's introduce an example of stream processing. Smart electrical meter systems for businesses typically generate millions of data points that are widely dispersed and not ordered. The time required to clean and convert this data makes efficient, real-time processing impossible for traditional solutions. This scenario shows how you can configure TDengine stream processing to drop data points over 220 volts. Find the maximum voltage for 5-second windows and output this data to a table. First, let's create a database with the required supertables and subtables. Then we can create a stream. Finally, we can insert some sample data. Now we can execute a query on the stream that we created. This example displays the power of the stream processing component in TDengine. If you'd like to know more about TDengine, you're welcome to download the source code from our GitHub repo and visit our official website at tdengine.com.